So let's get started. Back in the day, when I had a lot less white hair, there used to be one problem in networking. When networks were simple, someone used to trip over a patch cable, an Ethernet cable, and all you had to do was plug that patch cable back in, and things would be hunky-dory. Fast forward 20 years, I have a lot more white hair, networks have become more complex, and there is still one fundamental problem, and that problem is Wi-Fi sucks, right? So regardless of whether the problem is on wired, WAN, cloud, application, it is always the Wi-Fi that gets blamed. And the ground reality is that when Wi-Fi sucks, people don't say that the RF is to blame, they say you are to blame, right? That is what we are here to demystify. So before I start, I wanted to have a quick show of hands. Raise your hand if you have dabbled with a Mist infrastructure. Okay. How many of you are HPE or Aruba customers? Wow, 90% of the room almost. And how many of you are others? There are a few straddlers, okay. Welcome to the new world, okay. So the rest of the session, we are basically going to demystify, quote unquote, demystify how Mist helps you understand the Wi-Fi sucks problem, helps you remediate it. You have heard Rami's session, Sujay's session on our vision to a self-driving network. I will set the backdrop for the session today, and then I have two great friends, Wes Purvis, who is the business leader for Mist Wireless, and then someone very close to the Mist family, Kevin Mortimer from University of Reading, who is going to share his experience with the Mist transformation. So really, if you talk amongst yourselves, or you talk to your end users or your business leaders, the IT leaders, you're going to get a few repetitive themes on what is causing pressure on your networks today. Your business leaders, the lines of businesses, are putting constant pressure on you around digital transformation. It could be a location-based service, some application that you have to move to cloud. It could be a 6 gigahertz implementation. So everything needs to happen, and everything needs to happen really fast. While at the same time, the number of applications are increasing, the number of devices are exponentially increasing. In 2025, I think we will have about 35 trillion connected devices, right, in the whole world. So that brings in a level of complexity, right? You will have new attack surfaces that are going to come on, new security constructs. For 6 gigahertz, you'll have WPA3 that you have to think about. But one thing is not changing, is that you are not getting more budget, you are not getting more resources, and you have to do everything right now, right at this moment. So the technology and the architectures of past years are not going to help solve this problem. You can't really solve problems unless you get visibility into what those problems are. And if you can't see those problems or don't have the right metrics, you're not going to be able to solve those problems. And that is where enter Mist and enter the AI for networking, which is very relevant for campus and branch networks. So if you actually look at the Juniper Mist portfolio stack, on the left, you'll see a full stack meant for the distributed enterprise, the campus, and the branch for wired, wireless, NAC, SD-WAN, SASE. And on the right-hand side, you'll see networks that are built to support AI workloads. You've heard a lot about it in the networking session. The QFX series data center switching, the data center interconnects, the core routing. And so with the Juniper Mist portfolio, you're all really set up for an AI native self-driving network. Now, what this Why are we so confident and we have conviction around self-driving? One is that we have built our platform in an AI native way. It is not AI bolted on 20-year legacy code. It is not AI sprinkled on a canvas. It is really built ground up to get the right level of telemetry and to be able to then provide you with insights and recommendations. The step function in the AI world for us at HPE Networking, whether it's Juniper Mist or it's HPE Aruba, is the agentic mesh technology. I think that is going to help us, power us on our way to self-driving. There are a few examples that you have seen in the Wi-Fi world, how when you are capacity constrained, we automatically tune radios to support more capacity with more radios on 5 gigahertz, cancel the 2.4 radios, repurpose them for 6 gigahertz. All of that is real, and all of that is here and now. And so if you actually ask me, what are the things that are fundamentally different for Mist and why we have such strong conviction? Yesterday, if you have attended Bob Friday and Sudhir's session, Bob says good grapes make good wine and good data makes good data science. So when we build the Mist infrastructure, the operating system, the code that is running on the AP, every single line of code is meant to provide telemetry to the cloud. Every developer in Mist keeps that the first and foremost of their development principle, that a line of code written needs to be able to provide insights, and for that you need to stream telemetry into cloud. Every user, every minute, we take session data back into the cloud. Every asynchronous event that happens in the network, I can't connect to my network, or I am connected and my DHCP lease expired, or I can't get radius authenticated. Each of these asynchronous events are also taken real time into our cloud, and that is basically what powers a lot of the AI ML algorithms and models that we have running in the cloud. What really gives us agility is our microservices architecture. Whether it's on the Aruba side, whether it's on the Mist side, you heard Sujay talked about the microservices architecture is develop once, deploy twice. And the microservices architecture, the beauty of it is you are not stuck in a 20-year legacy world where suppose you have a frag attack vulnerability or you have a log4j vulnerability. Back in the day, you had crack attacks and crook attacks. All of those can get remediated really, really fast. You don't have to qualify things for 9 months and deploy after a year. 80% of our customers are patched immediately after public disclosure of a vulnerability. And that's just one example. There are numerous examples how the microservices architecture helps you in rapid deployment, rapid troubleshooting. And then last but not least, Wes is going to talk about our portfolio, and many of our access points are built in with a virtual Bluetooth antenna array. Back in 2014, 2015, Apple and Google had ratified the iBeacon and Eddystone protocol, and every single mobile device, compute device that has been shipping since 2015 has a BLE chip built in. What that allows you to do is get a digital ramp to connect with the end user device, and that is how we can enable very granular 1 to 3 meter location accuracy with 90% confidence. And last but not least, everything that Wes is going to show you in a demo is probably 60% of the capabilities. Our platform is built with 100% API-driven mindset. In fact, our dashboard leverages the same APIs that many of our customers use for their own automation needs. We can make you drink data through a fire hose, whether it's a webhook, whether it's a WebSocket, whether it's a RESTful JSON blob that you want to ingest for synchronous data. The proof really is in the pudding. And what I would say is, you've heard Sujay talk about user experience. We are not here to solve the access point green and the controller green and the switches green problem. We are here to solve user experiences, and user experience, the start and end of it is all about getting the right data set, getting the right telemetry into cloud, applying all of the models. If you look at the global heritage of many of the Juniper Mist customers, a large logistics company with 60,000 access points deployed geographically in 112 countries, they have undergone a 96% reduction in trouble ticket. If you look at one of the Fortune 5 retailers with about 5,000 retail stores in North America, many more globally, used to deploy about, I would say, 5 stores a night back in the day. They are now at a velocity of about 20 stores every night, so that they can refresh their infrastructure rapidly, right? So fast deployment, fast troubleshooting, mean time to innocence are all hallmarks. And if you ever talk to a customer that has undergone a Mist transformation and a migration from a different vendor, you are going to see these themes resonate over and over again. The best way to understand the Mist portfolio, at the very bottom row, you have hardware devices. Unfortunately, we still need hardware. Someday in the future, hopefully, we are going to make access points out of thin air, and you'll get RF without deploying access points. Till that time, Wes will have to continue to produce good access points. And then you have a portfolio of switches and routers, but the real value add is in the above 2 layers. What we never think of our dashboard as a management dashboard. It is basically something that allows you to give assurance for end user experiences, right? And that's all the wired assurance, wireless assurance, WAN assurance throughout the portfolio. The top layer is the face of all the AI in the system is captured as part of Marvis. And Marvis has different facets. It has Marvis actions that give you a cup of coffee view of the morning that tells you, if you don't do anything with your network, look at these 5 things. Marvis never lies. It may not catch 100% of all problems, but problems it will catch are really problems you should pay attention to. So there is a Marvis action framework. You saw the demo today that Sudhir gave. There is a conversational interface, a system where you can interact and you can get now agentic intelligence giving you really deep telemetry and root cause analysis of problems. You have Marvis minis, which are without any users. When there are no users in the network, how do you know that things are going right? There are agents deployed across our infrastructure that is constantly streaming telemetry back into our cloud, discovering problems, learning the topology without you having to lift a finger. So that is basically the backdrop. I will now turn it over to the one and only real Wes Purvis, as he calls himself on social media, to take it away.
Okay, thank you, Sanjoy. Okay, so that is Mist in a nutshell. The remaining portion of the session, go through a little bit of the portfolio. I'll jump into a demo, and then we'll wrap it up with an interview with Kevin. So from a Wi-Fi 7 perspective, this is our shipping portfolio, starting with the AP47, which is our flagship Wi-Fi 7 access point, tri-band, tri-radio, 4x4, dual 5 gigahertz, dual 6 gigahertz. It has VBLE for location use cases. It has ultra-wideband for other location use cases, 2 10 gigabit inputs. It can be powered by, on both ports. It's a fantastic access point, and there's actually 3 models there. There's the 47, 47D, which has built-in directional, and then 47E for external antennas. And then we've recently announced the mid-tier and outdoor portion of our portfolio, which is the AP 36 and 37. The difference here is the 36 has Omni BLE, where the 37 has the VBLE antenna array for the high accuracy location. Both these APs, the Wi-Fi specifications are the same, so 4x4 on 5 and 6 gigahertz. We feel the 4x4 is important, so we wanted to bring it down at a lower price point. And then 2x2 on 2.4. And then the 36M, M for multi, it has both external antennas as well as directional antennas. You can switch between in software. And then lastly is the outdoor AP, which is the AP66. This is brand new for us. There's the 66, which is the omnidirectional model, and then the 66D for directional, again. This is a theme. But this directional has 3 different software-definable antennas. So one AP, but with 3 different coverage patterns. It has a wide 90 by 90, a narrow 30 by 30, and then an in-between, which is a rectangle, 90 by 30, meant for hallway or even in like warehouses. We'll use it in kind of top of rack or in high racking. And just to spend a little bit more time on the directional antennas, it's new for us, and we think it's something that really will make a difference in deployments. So we've seen a trend over the last 5 to 7 years where access point deployments have become more dense. And as you get increased AP density in everyday deployments like an office or wherever it may be in a classroom, sometimes the roaming can be suboptimal, right? Where if you've ever experienced a sticky client, a lot of times that's just the density of APs is too high. Also, when you have a high density of APs, the co-channel contention can also be an issue. So the APs with the built-in directional antennas are meant to help some of those things. So people deploy highly dense networks because they want the capacity, right? There's increasing demands on the network with real-time applications like Zoom and Teams used every single day. So the 47D, the 36M have both built-in directional antennas with a 60 by 60 degree pattern, and these APs can be deployed in place of a regular Omni antenna access point in a lot of environments, right? It's not, they can also be deployed in specialty use cases, but we feel that there is tremendous benefits to having this directional antenna AP capability in everyday office environments or other environments where you're ceiling mounting the AP and it's providing coverage directly underneath, and it helps with roaming. It helps high performance without the added complexity or cost of external antennas. From where we are in the industry, we're in the Wi-Fi 7 mindset. So we've actually seen very strong adoption starting with 6 gigahertz. We're anywhere between 20 to 50% of our clients out there, we're seeing 6 gig. From a Wi-Fi 7 perspective, Wi-Fi 7 is where Wi-Fi 6E was 3 years ago. So about 10% of the clients we see as Wi-Fi 7 clients, and that will continue to increase just like Wi-Fi 6E did. If you're thinking about deploying Wi-Fi 6E, Wi-Fi 7, there's 3 primary considerations to think about. So one is security. You'll have to move to WPA3, so make sure that even if you're not thinking about a migration, you should start to get familiar with WPA3 in your environment. From a design perspective, we recommend a capacity-based design for 6 gigahertz on Wi-Fi 7 networks. And then from a switching perspective, the APs need higher power. They need BT power for full function and can benefit from multi-gigabit Ethernet connections. However, don't let that stop you. We have many customers who deploy these APs on 802.3 AT power and 1 gig links, and then those that are looking for the maximum performance will deploy on PoE++ and multi-gigabit ports. we have a solution called the Mist Edge. And the Mist Edge is used in many of our large environments where today you may be using a centralized controller-based architecture. And the Mist Edge fits in those environments to help with high scalability, seamless mobility in, let's say large campuses, or even tunneling from remote sites, or centralizing a guest kind of workflow. We're introducing a new Mist Edge model. This fits in the middle of the portfolio. It has four by 10 gig interfaces and supports up to 2,000 APs and 20,000 clients, and they can be clustered, for high availability and those kind of things. So with that, let me switch over to the demo and show you what what actually things look like in the Mist portal. So this is Mist, and okay, I can use this one too. Great. Okay. Well, can we leave it right there? Yeah. So this is the Mist portal. The page that we're looking at here is the service level expectations, the SLEs, and this is the heart of Mist. This is what many of our constructs are built on. Sanjoy talked a little bit about our journey to get to self-driving, and how we get there is by having really solid data fundamentals, and the SLEs are what take our data and first level of aggregation and slicing and dicing the data into different ways so that it's consumable and actionable. So the SLE framework will take data in and then output that data into certain classifiers to help identify failure scenarios, and then you can further drill down onto what is the actual scope of impact of those failures. So there's really two kinds of Wi-Fi failures. Everything kind of boils into those two. Sanjoy touched on them. The I can't connect and the Wi-Fi stinks. So these first two SLEs are time to connect and successful connect. These answer the question of, are users actually connecting to the network? And then there's several other SLEs, coverage, capacity, roaming. These answer the question is the Wi-Fi working well? And the framework between these is pretty similar. So just to show successful connect, this is a binary yes or no. Users are able to connect to the network. And so what does it mean that a user can connect to the network? Well, they should associate to the AP, authenticate to the network. They should receive DHCP, resolve ARP, and then resolve DNS. Right? And if you haven't completed those steps, or one of those steps has failed, then we don't consider you connected to the network, and we'll show that in the SLE. And so we can see over time when failures are occurring, how many clients are on the network when that's happening, and then for some of these classifiers, we can actually go a level deeper. So if you want to see, all right, I'm having DHCP failures. Why am I having DHCP failures? Well, it's due to DHCP incomplete, which means that the server sent an offer, but the client never did anything past that. It ignored the offer. And then from here, we can drill into, all right, who is actually having these problems? Right? What type of servers? Is it a particular DNS server, DHCP server that's causing me problems? Is it a specific device operating system, like Mac OS Sierra? Is it happening on a specific SSID, specific device type? Is it a 2.4 versus a 5 gig versus a 6 gig issue? And the way that you read this is, so the overall success of this SLE is 84%. What does that mean? Well, 84% of the connection attempts succeeded. 16% failed. And of those 16% of failures, 98 are due to authorization, less than 1% due to DHCP. And then if I look at, I'm getting in more deep into the data, the distribution here, the wireless bands. So of all of my successful connect failures, 99 percent of the failures are happening on 5 gigahertz. And then the 5 gig band, when clients are connecting on the 5 gig band, they're failing their attempts 22% of the time. So it's useful to have the overall impact to the SLE and then the kind of singular failure for that particular vector that we're looking at. And it's this same concept for capacity and roaming as well. So capacity SLE measures when clients are connected to an access point, how much headroom do they have? Is there available capacity for them on those access points? Right? We're not just looking at raw channel utilization and no clients are connected. You may not care as much about that, but when their clients are connected, you want to know, are they do they have sufficient capacity wherever they're connected? And the capacity SLE breaks that down into four different categories. So there is client count and client usage, which is my own usage, right? This is clients connected to my AP, and they're causing the utilization. Then there's Wi-Fi interference. Wi-Fi interference is other APs on the same channel. That's generally bad. But if those APs have usage that are contributing to my clients not able to pass as much traffic as I would like, then that will show up here. And then lastly, there's non-Wi-Fi interference, which is non-Wi-Fi interference, exactly what it sounds. But the same exact framework that we looked at before, where we can see, okay, there's the threshold here is 50%, and we're achieving that 95% of the time. You can see the different buckets of how much available bandwidth there is, timeline to see how many, when the failures are occurring and what type of failure it is, and then the distribution again of the different devices and bands. And then I also like to look at the map view so you can visually see which APs have the worst capacity. And from here, then you can get into the specific clients and APs that are having an impact. So if I go back to successful connect SLE and I go to affected items, I can find a particular user. All right, so this user is failing 100% of the time, actually contributing to 82% of the issues on the SLE. But if I click on this client, it'll tell me, hey, there's authorization problems, it's client specific. That's good. We know the scope of impact. But then I can go to the insights page, and this is where we get down to the nitty-gritty of what's actually happening under the covers. So we're maintaining about 150 different user states that we're getting from the clients. We get statistics sent to the cloud. Actually, client statistics sent every 2 seconds. It's an incredible resolution. Every 2 seconds. But then as events happen, so connection events like authorization and DHCP and DNS and ARP, as those are happening for each client, they get sent to the cloud. And overall in the cloud, we get billions and billions of those events per day. So I can look here, okay, this client has failed authorization. It's due to a possible PSK mismatch. But the very nice thing is, if you look, there is a paperclip in this event. And when there's a paperclip, that means that we have a packet capture. So Mist is automatically taking a dynamic packet capture of these failure events. So we're already capturing, but when there's a failure, we trim off that part of the capture only for that client and ship it up to the cloud. There's no data in here. It's just the metadata on the packets. So we can see, hey, there is an authorization failure, and which step, in this case, in the four-way handshake, did it fail? And there's a PCAP file I can just download and open up in Wireshark. So that's the SLE construct. This powers kind of everything that we do. So this part powers our Marvis actions, which Sanjoy alluded to. This is the morning cup of coffee view he talked about, and there's various different types of actions in here. So some of them are authentication failure, DHCP, ARP, DNS failure. So when, let's say there's a DHCP problem, it would show up in the SLEs, but you would actually get your alert from a Marvis action that this is something to go investigate. What is the scope of impact, and when did it actually happen? how many clients are impacted, and then there would be a trending graph as well. We have a capability called Marvis Minis, so we have a rich set of client telemetry data, right, coming in, and that's very useful when you have clients on the network. But let's say overnight the usage may be low. That's one area where the Marvis Minis, which is a synthetic test that runs off of the access point itself, can come into play. So there's also a Marvis Minis SLE. And it's performing many of the same things that a client would do, right? It's on the client VLANs, it's performing connectivity tests, ensuring it can get DHCP and reach certain applications that you can define or will automatically specify. So for example, here, application failure, we can, application Marvis Minis SLE, we can see there's some application reachability, and then internet services, which means there's latency and jitter added in. One piece that I should mention is the radio management, or RRM, as we call it. This is one of the very best parts of Mist. It's the RRM of assigning channels and power. I believe is, to me is the best in the industry. Where we go deploy, I can't think of, any customer that does not use our RRM, right? It's that good in assigning channels and avoiding interference. But we provide, some metrics around what is the system doing. So you can see the noise floor in the site and how many neighbors does each AP hear, how many co-channel neighbors does each AP hear, and then the number of APs per channel, and then the distribution score. If you've ever come across a network where all APs are on channel 36, that's what this metric is for. So you can see the distribution of the APs amongst the channels, and then density, which is how dense, how many APs does each other AP hear. And then there's some visualizations to see that channel density as well as the power distribution. You can see the current radio values, and also this is data that's coming from, coming from our dedicated scan radio, to what is the utilization on every single channel as heard by that single AP. And then there's essentially an audit log, an event log of what RRM is doing. So you'll see, scheduled RRM in the event, and this is RRM running once a day, saying, hey, yep, this is what I've learned over the past couple of days. Let's actually make this the channel and the power. You may also see, radar, DFS radar detections, and also the APs reacting when there's interference. In this case, there's non-Wi-Fi interference that this AP is avoiding. So I think maybe the last thing before I bring Kevin up is just a little bit about the hierarchy of Mist. So Mist is when our customers deploy Mist, right, they will deploy within an organization, and then that organization would have one or multiple sites in it, and a site is typically a building or a location, and then the devices, the access points, the switches go inside of that site. So in this case, this is our demo site in Cupertino, but there's actually 12 APs here deployed in the Mist office, and then the configuration is applied to the site, and so when an AP is placed in the site, it just picks up the configuration. You're not individually configuring each AP, and then so typical experience is somebody will plug in an AP, they can use our mobile app to claim it to the site or add it to the site, and once it's in the site, it will become operational and start servicing clients. And then from that app, users can take a picture, can place it on the floor plan, and write some notes if they want to, and then move on to the next AP. So yeah, I think that's probably a good place to bring up Kevin and ask him some questions about his deployment. Okay, so hey, Kevin,
Hey.
want to introduce yourself a little bit?
Yeah, sure. So hi everyone, Kevin Mortimer, University of Reading in the UK. We're about 35 miles west of London. We have 26,000 students and 4,500 staff. And we actually have 3 campuses in the UK. We have our main campus, which is over a big, wide green area. It's about 1.5 miles sort of across the campus. We have a smaller campus in the middle of Reading, and then we actually have a campus which is in a place called Henley, which is where we do exec education as part of Henley Business School. We do have a campus in Malaysia as well, and that's my next project is to roll out Mist there.
Okay. Could you describe your Mist network? Tell us a little bit about it? What you're doing, what you have?
Yeah, sure. So I guess if I go back to 2019, we had an aging controller network that we had to refresh. So we looked at the market and we come across Mist. What was really exciting about the product was the VBLE capability as well as the Wi-Fi altogether, giving us more of that location knowledge that we didn't have before. So we started a Wi-Fi refresh in 2020. We did a building by building approach to that. We then quickly realized that we needed to actually rethink some of the way we'd done that, because we treat everything as a building, but as Wes was saying, in your organization you have sites. So we then started clustering some of our buildings together to allow fast roaming between each of those, because otherwise the client was having to do a full re-authentication between buildings. And then the Mist Edge came into play and actually made that whole piece a lot smoother as well. So we've then rolled out wired assurance, so that's putting in the Mist wired switching in place. And that's given us, reduced our footprint of switches from over 1,000 to about 400. We've moved to much more of a Wi-Fi first position as well. And we are now embarking on a access assurance project using the Mist NAC. And for us, one of the real advantages of that is that we have tried multiple NAC solutions in the past and always struggled to kind of get it over the line. Within an hour and a half, we managed to get the NAC assurance piece working for us. So that was quite a nice little surprise, given given some of the issues we had. For us, edge roam is always a bit of a challenge. It uses radius, and we're really happy there's a Marvis client coming out now, which allows you to do a certificate onboarding as well. So that's going to really transform our student experience for the bring your own device space, and students have quite a few of those.
Okay, so you started with wireless,
Yep.
went to wired, and now started with NAC.
Yep.
Great.
And we've had Juniper SRX for our firewall since 2013 as well. So
gotcha.
Full stack in that sense.
Okay. How did you approach the migration from previous vendor in terms of going building by building, or just any thoughts or considerations when you migrated?
Yeah, so we didn't have Wi-Fi 6 capability at that point, so we still had 2.4 and 5 gigahertz. So we did pretty much a like-for-like replacement. One of the problems that we did have is that where we were vertically mounting the APs. For Mist to work, you need to have them horizontal for the antenna array. So we looked at some metal brackets to kind of do that angling. But in the end, we actually went and had some 3D printed brackets made for us as well. So we had 15,000 of those made, 1,600 of those made, and allowed us to do that pivoting piece. And then obviously the great thing about plastic, it doesn't interfere with the RF as well. So we went out building by building and did a rollout. We increased our AP count by about 50% as well, just filling some of the extra gaps we created. And now we're actually looking to expand more of our Wi-Fi, outside Wi-Fi coverage as well, as we're trying to do a bit more of the community piece and bring in the public in and using our land.
Did you run into any roaming issues during the migration?
Roaming was our biggest issue, and I think as I alluded to, that's one of the reasons why we started out building by building.
Yeah.
We thought that was the right way to do it. But then we found that as people go in between buildings, because they're quite close to each other, that they were having a lot of authentication issues. They were dropping their calls as they were walking around. So that's when we created like quarters on our campus and moved people at sites, multiple buildings into sites to allow that fast roaming to take place of the 11R.
Yeah. Typically, we would when people are migrating, if you homogenize kind of like the wired network, make sure L2 is the same under the end of the covers. The roaming can work pretty well.
The great thing about Wi-Fi is it does a segmentation sort of naturally, if you like. So we have just one big /16 for our Wi-Fi network. It's a lot harder to do that on wired.
Yeah. And maybe one last question. How has Mist helped you? Has it helped you?
There's been quite a few hidden gems, actually. And I think if anyone was in the location talk yesterday, you heard about how Premium Analytics was really helping with some of their space, some of their data on that. Our space team, they use the Premium Analytics data to work out when they're going to close buildings, when they're going to service buildings. So it's bringing some actual business value now as well, where it's not just a technology that we have in the IT function. But there's a lot of talk about reducing ticket numbers. I'm not too concerned about the actual ticket volumes because students are always creating problems on the network. But for me, I want to be able to fix them quickly. So we used to take around 4 hours for an engineer to troubleshoot a problem and then make any modifications and changes they need to make. It's now less than 30 minutes for us to actually do that, and that's logging into the Mist, going to Marvis, getting the output, and seeing what we need to do. So for me, it's our ability to fix things quicker is a massive saving for my engineers.
Very nice. Okay, well, with that, I think we can wrap it up. Just a few things. If you have not already come to the expo and seen the demo booths, go ahead and check that out. There's a large Mist presence in the networking section of the expo, as well as an Aruba presence as well. You can come touch and feel the APs in the petting zoo, and don't forget to participate in the Airheads and Elevate communities. And the very last thing is, not here. There should be a survey. So please go take the survey if you have not, or if you haven't taken a survey yet for any session, you should. But for this one in particular, 5 stars only, please. No, just kidding. It really does help, so thank you.